Okay, hi kids. This is a preview of the activities for February 4th, which you can see here. And this is intended for students that either couldn't make it to the class or um, would like to review what was said in class. And this will be brief. It's just an introduction. Just try and keep it to a couple of minutes. So let's see. Just as a reminder, you should have this lessons page bookmarked in your browser. If you look on the Year 7 menu, you can get, whoops, sorry. If you look on the Year 7 menu, you just need to mouse over on that. You don't have to click it. You can get to several things: the Getting Started Guide, the class handout, which we'll talk about in a minute, a list of Scratch challenges, and the MLA reference, which we'll talk about later. This is how you set up your bibliography. Now, if you look at these Scratch challenges, just quickly, there's a list here, and we will go through all the first 8 together in class. And later Miss Mameni and I, we will add hyperlinks to these so that you can quickly jump to the instructions for each exercise. Now, for February 4th, Tuesday, we'll talk about the design cycle, Scratch, and start practicing. For the design cycle, I guess there was a little confusion about whether the screencast should be completed by today. It does say in the homework down below for January 21st that the screencast should have been completed for homework prior to the break. So if you haven't finished it, we can spend a little bit of time working on it in class. Now for Scratch, we'll talk briefly about what Scratch is. There's a short video here. We can watch that in class. If you're not in class, of course, you can watch this at home. And we'll just talk about an overview, and I'll do that right now. So over here is my Scratch window. And if you've never seen Scratch before, now I suppose I should get rid of, I'm going to turn this off for the moment, or minimize it so it's out of the way. There it goes. So this is Scratch, and Scratch is based upon creating sprites or actors that live and behave in this stage. The stage is this box here. The cat is a sprite. There are many kinds of sprites. You can create your own sprites. Now each sprite has some code associated with it, and that's where you create the behavior, namely what will the sprite do. Each sprite can have several costumes. You can create as many as you like, and the sprites can make sounds, including your own voice. You can record your voice and make the sprite sound like you, or you can use built-in sounds. Now over here on the left, there are, well, 2, 4, 6, 8, 9 palettes of programming blocks. In Scratch, they're called blocks. In all computer languages, they're called instructions. These are the instructions which you will use to compose a program. And I'm not going to go through them all. There's a lot. We will focus on a relatively small subset of these. Here's where you name the project. You can share your project, and that's important. In order to get your project into your studio, which you will do, and we'll talk about that in the exercise, you have to first share it, and then you have to add it to your studio. You cannot add a project to your studio until you first share it. There are some tutorials available, so you can look at how certain things are done. For example, if you want to make a chase game, here's an example. So let's go back. Yeah, that's about it. That's about all I want to say. Oh, this is information about a given sprite. So if you click on a sprite, you could have many sprites. If you click on a sprite, you'll see some information. Oh, look at that. I got a message from Yun Dong. Later, Yun Dong. Yeah, you can. He's persistent. I lost my train of thought. So you can click on a sprite and you can get information about that sprite. And notice over here on the right is the stage. So the stage has information associated with it as well. And note that you can create code for the stage. Now, stages don't have costumes, they have backdrops, or yeah. And the stage can also make sounds. So that's very important, and we will talk about the stage. So now I'll switch back to the sprite, and now we're in sprite mode. So that's a quick overview of what the Scratch environment looks like, and of course we'll talk more about this in class. Now the last thing we are going to talk about is the practice. So we have a bunch of exercises. Exercise 0, why 0? Well, that's a long story. So if I click on here, you will see the instructions for doing the exercise. And by the way, notice this left panel over here. If you don't see it, if you open any Google document and you don't see the navigation panel here, click on this button. This is how power users navigate documents. They don't scroll up and down. That's a waste of time, especially when the author of the document has provided this for you. So here we just talk about the objectives. Here's some background information. By the way, this exercise is about the geometry of the stage. That means the shape and dimensions of the stage and how actors can move around on the stage. So it's basically, I won't read all of this for you, but I think it's fairly self-explanatory. If you have questions on this, you can, of course, ask. But this is just background information before we get started. The objective here is to learn the dimensions of the stage and practice moving a sprite, adjusting its x and y coordinates. That's one of the characteristics of a sprite. You can see it here. This sprite has a x and y value, which determines where the sprite is located on the stage. So here is some information and some details about the geometry of the stage. And what do we say here? It's a two-dimensional plane with an x-axis and a y-axis. Now what it doesn't say there, and what it should say, is how wide the stage is. And you'll be able to see it down here. Now this is a backdrop which you can use for your stage, and you'll use this backdrop when you do exercise 0. And as you can see, the y value ranges from positive 180 down to negative 180. That means that the stage is 360 pixels, or I don't want to say spaces, but picture elements. 180 pixels tall and 480 pixels wide. So x, I think as you know, if you move along the x-axis to the left, x gets more negative. And so the minimum value for x is minus 240. If you move to the right past 0, 0, x starts becoming positive, and the maximum value is 240. So the stage is 480 pixels wide and 360 pixels tall. So scrolling down here now, pseudocode. I don't have time in this screencast to talk in detail about what pseudocode is, but suffice it to say, this is a practice we use for getting started. It's a way for you to create the logic. In programming, we say you should resist the urge to code, meaning you should understand the problem before you code. And pseudocode, pseudo means fake or not quite real, and this is I'll try to add an example here for you to look at, but it's a halfway step between the problem which exists in your mind and the source code which you're trying to give to the computer. And it looks like code, but it reads like English. Now, when you're doing this project, some best practices to keep in mind. We want to reduce the number of green flags we use. Ideally, we would have just one green flag, and you always should comment your code. Now, the exercise itself is you're going to create a project, name your project like so, add the project to the studio. That means first share it, then add it to the studio. You're going to use the built-in pen in Scratch to make a sprite draw 2 squares on the stage. Each square should be 100 pixels square. So you're just drawing the edges of the square. You're not going to fill in the square. And you're going to draw each square in a clockwise fashion. The first square should be red, and here we give you the starting point. So 100 by 150 is the upper left corner of the red square. Here, the second square will be at a different location on the stage at minus 100, minus 50. So that's x is minus 100, y is minus 50. It's always x, y. And let's see, what else do we have? And here are some examples of blocks that you will find handy in doing your exercise. And I think that's about it. Now, we will also add a video showing how your project should behave. We won't show you the source code, of course, but we'll show you a video of how your project should behave. All right, then. That's it for now, and see you next time in class.